So for the topic for today, this is module 6 of the track, and there is about, or is going to be talking about, administering network traffic. I'm going to be using I just wanted to use this to show you the topic. On this particular module, we are going to be looking at how to configure network Azure load balancer, what are Azure load balancers, and then what are load balancers generally, and how to configure one in Azure. And then we'll look at an application gateway. Application gateway is another type of load balancer that you can have in Azure. Then we have network watcher. Network watcher give you access to a lot of tools that you can use to manage and monitor traffic across your IaaS, that's infrastructure as a service resources in Azure. So moving on, let me go to the website. I think I want to use Microsoft Learn for this one. So I'm going to share and reshare my entire desktop now. Okay, so when we talk of application, or when we talk of load balancing, there are times in an organization, depending on the use for the particular application that they require, such application might require what we call resiliency. And then so we want a situation whereby it is resilient to failure and it can scale at any time. Scale means when there is an increase in demand, increase either the resources or the number of devices or applications within a set, or when the demand decrease the resources accordingly. So it's able to help you either scale up or scale down. So now, in such instance where you have applications that you need to make highly available, that means it cannot go down. We can take an hospital portal, that's a patient management portal, for instance. For an hospital, it's very critical for their patients to easily and quickly be able to access the website or the application and be able to book an appointment and even have other communication right from that web application, or that application right from it, to be able to talk to their doctor, talk to their the consultant doctor and the rest. So you look at such scenario. Now, if you now have the need to make such application to be very, very highly available. Highly availability is different from resiliency. When we say something is highly available, it means we have that application or that server. There are two of it that are running, and they are running exact the same type of service. Not that one service is different from the other. Server 1 and server 2 are doing exactly the same thing on the network. But then, what if server 1 goes down? Obviously, server 2 is going to, you now have multiple servers that is hosting the same exact services. How do you ensure that it's not just one server that is doing all the work when people make requests to that server? So patients go to the hospital's website now and make a request on the, try to do some things, book an appointment, for instance, from the website. And it's happened that every request, every patient that hit the website to do something, only one server has been responding to them. So load balancer in an environment, load balancer is useful in this case to help you receive those traffic from the user as it's coming from the internet or wherever it's coming from, and then distribute it and check which server and which server is available and send the traffic to them. Depending on configuration, there's what we call round robin. Round robin means if I have two servers, the first request that comes will go to server 1. The next request will always go to server 2. The third one will go to server 1. The fourth one will go to server 2. That is round robin. It's always ensure that it shares the load. If it is 10, It will share it up to the 10th node before it come back to come and give request to the first node. Then there is also another type of load balancing that is not round robin. This one, you can decide to say certain percentage of the traffic should always go to this particular server, and certain percentage should always go to this other server. Or you dedicate where you have multiple services that you are rendering from that infrastructure. For instance, you can say every request that comes for appointment, this one server should be responsible for any request that have to do with appointment. Another server should be responsible for any request that have to do with imaging, maybe like their scan image, like X-ray images and all of that. You can do that type of load balancing as well. So let's just jump in. Now there are different use cases for load balancer. And just like I tried to explain from the beginning, majorly the purpose of load balancer in an environment is you have a highly available resources, or resources that need to be highly available for your users to be able to access at any time and any point. Not just it being highly available, but also improved performance for that particular application that your users are accessing. So look at this diagram, for instance. We have the front end, we have the load balancer in the middle, and then you have your back end, which are the pools of your virtual machines. So now, for this to work, really, you have to determine what we call application tier. I think when we move there, there's in one of the conversation, we'll talk about multi-tier application. So there are different tiers when it comes to application design. There is what we call single tier. Single tier is a situation whereby this front end is a web service and is a web role like IIS, like that's Microsoft IIS information, and that's yes, Microsoft Internet Information Service, that's IIS. Then and there are other web services as well. Not PHP. The name just came and then just disappeared. But apart from Microsoft, there are other web services that you can use as well. So the front end actually represents the web service. That's the service that the user that is coming from wherever they are coming from will always hit, right? Then you have the middle tier. The middle tier is mostly your application. So the application itself is in the middle, and the front end get request from the user and forward it to the application. Then you have the third component of it, which is the database. Databases are usually to store data and must be secure all the time. But if you are using a single tier design for your application, it means all of those three roles or components are installed on a single server. They are all installed on a single server. Now, you have two tier. Two tier is where you put both the front end and the application. You put it on the same machine, while you put the database on a separate machine. That's two tier. Then you have three tier. Three tier is front end is standing on a separate machine, application is on a separate machine, and database is on a separate machine. That is three tier application design. So depending on the design that you have, your load balancer, it will determine where your load balancer is actually going to be sitting. So you have load balancer in this case in Azure. You have load balancer that can be used for different purposes. A scenario where you want to be able to load balance inbound traffic. Inbound traffic, that's from user to the server. From user to the server, that is coming in, the traffic is coming into the server. Then you have the outbound traffic scenario. Outbound traffic is now the server initiating the request and going out, maybe to the internet or to another server on the network. Also, when it comes to load balancer in Azure, you have different types that you can create. You have the public type, and then you have the internal type. We'll talk about them in detail in a bit. And then when you are something that you also need to know, that you need to be conversant with about load balancer, is that is about the components of that load balancer. One of it is what we call the front-end IP address. The front-end IP configuration is the IP is majorly just referring to the IP address that your users will always hit. That's whether it's IP address or you map that IP to a name. But that name or IP is what you will give to user. Anytime you want to access this particular service, make sure you type this IP or this name in your browser. When the name is query on the DNS on the internet or on your internal DNS, the load balancer then receive that traffic. Then there is what we call backend pool. Backend pool here are simply the servers or the services you are load balancing. So let's say the hospital portal, for instance, we have two servers that is hosting the appointment module of the hospital application. Now, those two nodes or those two server or machine, they are called the backend, and they can be put in a pool. A pool is just a group of computers that are doing similar work. Then you have what we call health probe. Health probes are component of the load balancer that will help you to check the state of all the members of the pool, whether to know the one that is up, the one that is down. So when he's able to tell the one that is up and healthy, then he continues to send traffic to those. But the moment he's not able to get response from a probe, so probe just means I ask you, are you there? Yes, I'm there. Are you there? Yes, I'm there. Are you there? Yes, I'm there. It means that a particular pool member is healthy, and it will continue to send traffic to that pool member that is responding. But the moment he's not able to get response from a particular node, it takes it as that node or that pool member is down, and it stops sending traffic to him. But it will continue to probe it so that he knows when the server come back up. And finally, you have what they call load balancing rules. So now, as the traffic are coming, you need to create rules. The load balancer work very closely with rule. Rule are a set of when this request come, check things like the address, the IP address, and then check the port that I want to access. Then check within yourself, forward this type of request, forward this to this particular device or this particular server, forward that request to it. So there must be a rule that is telling the request, that's telling the load balancer what to do with whatever request it receives from the user. And so I think I've already talked a lot. Now let's look at the various type of load balancer, which is majorly public and the internal load balancer. The public load balancer simply means it is public facing, it is internet facing. User can access any result behind that load balancer. They can access it from over the internet. If you look at this screen, that will be the image before you, you will see the internet cloud. There's a user behind this cloud. A user is sitting right here. Let me see if I can get something. Allow me to let's it. See. Maybe two. Now we have a user behind. This is the internet cloud. We have users that are behind they are on the internet, and every time they go to their browser to type http dot the hospital website, for instance, and then they hit enter, that request come from over the internet. The first person in it is the public facing load balancer. Then the load balancer collects it. The user has made a request on port 80, TCP port 80. Now, when you are configuring, your rule will translate internal, external port that is coming, an IP address, translate it to this particular internal port. So in this case now, we are using the same port. So there's no translation, there's no port masking, there's no port redirection. So that translation is usually called port redirection, where the ports that users are seeing or they are querying the service on is different from the port that is actually configured on the resources or on the server. So you call it port redirection, but that is not the case here. So we have users on the internet querying a service that we have on any of these servers, and then the load balancer receive the traffic because it's internet facing, is the first point of contact. You receive the traffic, then you look at its list in the back end pool, and who responded last that they are available. You send the traffic based on the configuration of who and who to send that traffic to. That is just majorly what the internet load balancer, is this internet? Yes, that's what the public load balancer is talking about, is internet facing. The second type of load balancer that we have is internal load balancer. So internal load balancers are load balancer that you create that is operational only within your virtual network or only within your network. So look at this scenario, this diagram here. We have series of SQL server. Like we said, databases should be secure. They should be kept securely all the time. Now, we have about 3 virtual machines also that are also running the same application. Now, anytime anybody access, so there might be a thought there that have the front end. Anytime there's a request come from the front end and hit this might be internal user now, an internal request, and hit the virtual machines. The virtual machine then talk to the load balancer, who will load balance that traffic across the different databases that we have. It might not be to load balance just the database. It might be to even load balance the app itself. So that's the way the internal load balancer works. It can be used for things like line of business application that is hosted internally for internal use purpose. It can be for resources that are behind a single virtual network in Azure. And then the other thing is, if you configure Azure resources and you didn't make it publicly available, but you configure VPN for people to be able to reach it via VPN, or even hybrid, extending the Azure environment to your on-premise infrastructure. That is the scenario in where you will use internal load balancer to load balance the traffic just internally for you and your users. So these are just things that I've already talked about. Internal load balancer is majorly within a virtual network. It's within a single virtual network. So this case now, all the virtual machines that you want to load, both the load balancer and the virtual machine, they must share the same similar network. They must share the same virtual network. However, they can be in different subnets, but they have to be within the same virtual network and also the same region. That is also very, very important. Then we talk about other use case for the internal load balancer. Now, in this case, we have things like multi-tier. That's the reason I explained that multi-tier application, where you have the front end sitting, in one section on one server. You have the application sitting on another server, and you have your database sitting on another server. And it will also be in a situation whereby you have your front end is internet facing. So in that case, you will have 2 load balancers here. One is receiving internet traffic, and when you receive traffic from the internet, it sends it to the internal load balancer. The internal load balancer then sends it to the applicable servers that is within the backend pool. But at no time will the internet load balancer come straight to the backend pool nodes that you have configured. So that's in another way to use internal load balancer. So how do you, one of the other things you need to determine when you come to load balancer is to determine the skill. So the skill that you want to use. That's when we talk of skill, it is referring to stock keeping unit. Stock keeping unit is a way to identify the type of resources that you are creating, or to also identify whether the feature. It actually tells you the difference between the feature of the ones like you have basic, you have standard, maybe enterprise. That is what skill. That's what it means, really. So for load balancer, when you are creating it, you have three options. You have three options. You have standard. Currently, standard is recommended. When we go to the website to try to create some things, you will be able to see it. Standard is the current recommended one. Basic is going to be end of life soon. So we'll only be left with standard and the gateway. Now, depending on the one you choose, will tell you the feature that is available on that load balancer. So when you are creating a load balancer, one of the things you need to consider is the subscription as usual. Every resource that you are creating on Azure must be hosted in a particular subscription. Also, every resource you are creating in Azure environment must also be hosted in a particular resource group. You cannot skip it. You cannot escape creating resources without putting them in a resource group. Then you have name is an important. Then you have region, and you have your option to select the school. Then you see here, you can choose whether it's public or internet load balancer or internal load balancer you want to. Remember, if the purpose is to load balance traffic that is coming from the internet, it will always be public, because you need people to be able to reach that load balancer publicly from the internet. So moving on, I think things to know, like I said, standard is one of the load balancer skill that is available. And then the standard offer, depending on whether standard, basic, or the gateway type, you have different feature that is available for you. So the standard now contain all the features of basic plus more, right? That is, so if we look at this, just comparing standard skill to basic skill, you notice right from the earth probe, the earth probe can only be HTTP and TCP. That's not HTTP. You know, HTTP is a non-secure transfer protocol for web service, while TCP is a connection-oriented protocol. That means when you initiate a request, the session is kept open until the transaction is completed. It doesn't close it. And then when you look at the standard for that in this category, you notice the standard supports HTTPS, that's secure access to the load balancer or to the resource that you want to publish. And then it also supports the feature of basic, which is on secure web protocol, and then TCP. Then when it comes to availability zone, when you are creating, you need to determine whether you want it to be highly available or not. So for basic, it does not support availability zone, while standard support redundancy. So you can do zone redundancy, for your standard load balancer. Then when it comes to front end, how many front end can you have? That's how many server can you have within your front end pool. Then you have just one for standard, and you have in terms of direction that you can use the basic skill for. In terms of traffic direction, you have inbound traffic, only traffic that is coming maybe from the internet users on the internet to the server, or is going from the web server to the database server. that is only one direction. But for standard, you can do both inbound and outbound, and you can, add security to them. The security in standard is definitely more robust than that of basic. Now, moving on, we have is to create how to create backend pool. So the first thing we do is to create the load balancer. After creating the load balancer, the next thing is to add things like the server, the backend pool. The backend pool, like I said, are the servers that you actually want to load balance. And those servers must, at least, they must be able to communicate with one another. So simply put, they should be in the same virtual network. Now, things to know when it comes to backend pool: a basic skill, a basic load balancer type can accommodate up to 300 pools. 300 pools, while a standard one can accommodate up to 1,000. Then also, when you configure backend pool, you can connect it to availability sets. You can connect a backend pool to virtual machines, and you can connect a backend pool to Azure virtual machines case set. So when we are talking about virtual machine, we'll talk more about these skill sets and then and other things thereabout. So let's quickly look at the Earth probe. When you are creating Earth probe, what are the things, what are the parameters that you need to take into consideration? By the way, while you are creating your load balancer, if you are creating your Earth probe, you have to create Earth probe. But if you did not specify any interval, the default interval is it fall back to 30 seconds. So every 30 seconds is going to make attempts to check the members of the backend pool to know which one is available. So that's by default if you did not specify anything. So now, how does it know? How does it tell that a server is actually up or down? You have a message is expected to receive a particular message. Oh, sorry, I said the default was 30. It's actually 31 seconds. So now it's expecting to receive a message. Each time you say hello, it's expecting to get hello back. And that hello must be equivalent to numbers. If you get a number from between 200 and 230, 290 something, between 200 and 300 dB and above, it's determined that particular node or node member is actually available and healthy. So that's the way it's able to know. Then now you have different, these are the probe. There are different type of probe. There's the HTTP probe, and then there is a TCP probe. TCP probe rely on a session that is open, and then it's until the activity is complete before you close the session. So it will continue to listen to what we call listener. A listener is just the port that you have created to be open. You have told the server, a particular server, to be listening on a particular port. That is just what a listener mean when it comes to probing within for load balancer in Azure. Now, we said one of the critical components for load balancer to also function is what we call load balancer rule or rules. So for it to know what to do with the traffic that is receiving from the users, you need to know, you have to create a rule, or you have to create rules that tell it what to do with those traffic. So here is a sample of rules that is being created for the load balancer 1 that we are creating. You have your rule name. You need to select the type of the IP version. So we have created a virtual machine that is using IPv4. There's no point for us to pick a rule, create a rule that is talking about IPv6. it will not work. So we have to also select equivalent of the IP configuration on the server that we are load balancing. And you have to specify the front end IP address. That's and then the backend pool. You have to create them, and you will specify the protocol that you want to use for that particular that you're using rather on that particular server. And these are the different. Then you specify the ports, the backend ports, and the probe. We created probe earlier. The probe we created earlier, you select it here. That's what is used to check whether the server, which of the server is up or down within the network. So moving on is for us to quickly see now how we can quickly create a load balancer. So I'm going to go into my my Azure environment. So I've created a few virtual machines that I have and want to load balance, right? So just to save time, I have to do that down. So now I want to create a load balancer. The first thing I need to do is you can search. You can actually search for load balancer, and then it will bring it up for you. Or we can also, let's just search for a minute. Let's just search for load balancer. Okay, I have one on the list here. I select load balancer. I've created one earlier, but let's see the process by which we create it. It takes some time. It takes about between 5, 10 to 15 minutes to complete the creation. So that's the reason we have to do a bit of the work down. So like we said, as usual, you have to select your subscription, and then you have to select your resource group. So I've selected that. Then instance detail, the name of my load balancer. I have this one that is already existing. I can call it LB2. That's load balancer number 2. Then let's maintain this region that we are. Like I said earlier, these are the different school options. And then you have standard, you have gateway, and you have basic. By the way, let me quickly show you something on the slide. We've been talking about load balancer. There are other solutions that you can use to load balance your traffic or your resources within Azure. One of it is the load balancer. The other one is the application gateway, which we are also going to talk about shortly. You have other options. You have what we call front door, and you have traffic manager. So each of them here, depend on what you want to do, you select the appropriate one that goes with the type of service that you want to load balance. If you notice, for the usage scenario, application gateway is majorly for web application. Majorly for web application. If you are looking at load balancing web application, you'll be using application gateway to do that. And then to optimize delivery, you'll be using application gateway. If you are looking at enhancing security of a global microservice web-based application, you'll be using front door. And then if you are looking at balancing traffic between inbound and outbound, then you'll be using standard load balancer. Then we have traffic manager. So look at the different protocols that each of them supports, right? And then whether they can be globally configured or global reach or not. So global reach means to be able to reachable over the internet. That's what it means. And then the security that is supported on it. So here is what application gateway. You will be using what we call WAF, web application gateway. Then for front door, it's also a web application. So you can use WAF, and you can use your standard NSG. For load balancer, is NHC. That's majorly where the security is. So I just wanted to quickly show you that. Let's go back to the site, to Azure portal. Now, let's create public facing load balancer. We have selected. You notice what happened. If I select internal, it gives me option for the 3. If I select public, it automatically remove gateway, that's application gateway, from the list for me. Now, the next thing we are going to create, we will move forward. Now, from this front end, that's the next front end IP configuration. This is where we are going to state, is it moving? Okay. So here is where we are going to add an IP. This IP we are adding here is a public IP address that people will be able to reach from the internet. It's not the server IP address. It is the IP address of the load balancer, the public leg. So we can call it AZ104 PIP LB2 PIP. That's public IP. Then it's IPv4 as well. And then we select the IP, the type. We have IP address, and then we have IP prefix. When you say prefix, it will give you like a slash notation. If we select prefix now, you put the IP, and then it will be in a slash notation format, but we'll use IP address. So now we have one that we have created earlier. I don't want to use any of that. I want to use, let's create a new one, or create a new one called maybe PIP, PIP2, LB2. Okay, LB2 PIP. So, and then the skill also select all of those. Now this is where we go, because the standard that we are creating, you see that it gives us option for redundancy, to be able to select where we want redundancy to happen. Is it one zone or multiple zones? So let's leave it as default, and we are going to select routing preference. We are going to select Microsoft routing, Microsoft network. Then I've clicked save to save the configuration here. Now, gateway load balancer, we are going to leave it as none for now, because what we are doing is not gateway, it's standard load balancer. Now, by the way, for the load balancer that we are creating, this particular one, standard load balancer is a layer 4 load balancer. There's layer 7. Application load balancer is, our application gateway is an example of a layer 7 load balancer. What application gateway does, or what application load balancer or layer 7 load balancer do, is it goes beyond checking just the physical hosts or the NIC that I cannot get response from this device. It goes to check the services, the application itself is aware of the application itself. That's the difference between a layer 7 and a layer 3, or a layer 4 load balancer. Now let's move on to backend pool. So on the backend pool is also empty. We are going to add a new one, and we call it BE2 LB2. Let's just put it that way, LB2 BE, that's backend pool. Then we select a network, a VNet. So in this case, like I said, we are supposed to have created a VNet. So let's just use the same VNet that we have already on ground. And the configuration we are going to be doing is the NIC is what we are for on that load balancer. Is to look for the pool member from the NIC that is configured for, that is configured with. Now we are going to add an IP here, and so here now, these are the virtual machines that I have in my environment. I have VM0, 1, 2. So let's select 2 virtual machines to be added to the pool, and then I click save. And the next thing is inbound row. So now I'll go to the inbound row. We do not have anyone for now. I can create. You will click create to add an inbound row. Remember, we said the row is what tell the load balancer the traffic you receive, what it should do with it. So now I'm creating an inbound rule. I will call it rule, that's LB2 rule. and then it's an IPv4 rule, and then the front end IP address, we created one earlier, so I will select it. Then also back end pool, we have created, remember we created a back end pool here. I will select the backend pool as well. Then we are going to maintain the protocol to be TCP. Now, what port is it that we are load balancing here? We can choose either port 80 that it has been configured with, or we will have a custom port that we configure but still not so secure. So now, the backend port is the same because the server is configured with just the port 80. There's no port. Now here, I need to create the probe. We need to specify our probe. Like we said, if we don't specify anything, it assumes the default of 31 seconds, every 31 seconds. So now I'm going to create a probe, and it's going to be AZ104, 104 LB, begin with number, with letter or number, end with, okay, underscore, okay, I'm not take that. So LB, then let's put underscore instead. LB2 probe, let's call it that way. Then TCP and port 80 is what. So the interval here, as against leaving the default of 31, we can leave it as 5 seconds, or we increase it depending on your requirements. Excuse me. So now I've clicked save to save that setting. So we now have a probe selected. The next thing is what we call session persistent, but we are not going to consider ourselves with this. Then idle timeout. So idle timeout, that's how long should it tell, how many, like we have set 5 minutes, right, for the probe period. Now if he sends in the first 5 minutes, he sends a request, an hello request to the pool, to the backend pool nodes, and one did not respond. Let's say server 0 did not respond, the first one. He keeps sending until it is this 4 minutes. This is a minute. So after 4 minutes, he reports that that server is no longer available. So you might want to reduce it. Oh, sorry. The minimum is 4 minutes. So we leave it as that. Then enable TCP reset and enable floating IP. That's not really necessary. We'll leave that as a default. Then outbound source network address, we are going to recommend it. So this means is to use if the servers themselves for any reason they need to go to the internet, they shouldn't go with their direct public IP address. It should be translated, that's their IP should be masked to another IP. Then we click save. I click. If you complain or anything, or it's coming. Belonging to the load balancer rule belonging to the load balancer of the same type and using the same backend ports. Okay, so this is understandable. This is because I have I've used that same port, right? I've used the same port, the same backend port. So let's say we have 81. Let's do 81. That's a complaint. Hopefully, same backend port. So is it responding now? Okay, yes, it has gone. So because I already have one before that is referencing the same 8080, you cannot allow multiple load rule to be created that contain the same port. So ports should be different. And then when you can create multiple rules. The rule will they will work in order that they are created. So the next thing we need to do is we don't really need outbound rule for now. We are going to leave it, and then we'll go ahead and say create, right? So now, like I said, I've already created one, but that's all we need to do. So let's go back. Now I have this load balancer that has been created. If we go into the load balancer, if we go into the load balancer, you are able to see the information of the load balancer. See the ports that is load balancing traffic for the probing, and then you have the front end pool. This front end pool, this is the IP address that was created for the pool. You have your back end pool. The backend pool is the list of servers that we have added. In this case, we added about 2 servers in this list. So we have our two virtual machine, 0 and 1. So now we have our probing as well. If I go back to the front end pool and I copy this IP and take it to my browser and hit enter. So mind this. So you see, hello world, who's responding to me? This is VM1. If I refresh now, it will not change immediately, but after a while, it will change to VM2. So maybe we'll come back later to refresh so that you can see it. So that's that with regards to creating load balancer. The next topic is going to be application load balance, application gateway rather. So let me go to that. So okay. So here, what are application gateway? Application gateway are used majorly to help load balance or work with web application. They work majorly with web application like HTTP, HTTPS traffic. That is what application gateway is designed to work with. So look at the diagram we have right here. We have a browser, and then the browser, whoever somebody, let's say a user is the one that has opened or fire up this browser. When you make a request to any of this server that is seated here, an HTTP request, the application gateway is the one that received that request. When you receive the request, there's what we call listener again. Listener is just the ports or the services based on port number that is available on those servers that you are load balancing, right? It send that traffic to the listener. The listener check the rule, the HTTP setting rule or HTTPS, and then it forward the traffic accordingly to the server that is supposed to receive that request. That's the way application gateway work. It is always in front of your far in front of your application, meaning that's the first person that the traffic will hit before it move on. Now, what are the things that we need to know or be familiar with when it comes to application gateway? We have application layer routing. So this is where I say it's a layer 7 application, is a layer 7 load balancer because it is aware of the application. It goes beyond the virtual machine, just the virtual machine state. It goes into the application layer to see what is happening before you consider a particular node, whether it's available or not. Then it uses round robin. That's round robin to distribute the load to the multiple servers that it is load balancing the traffic for. Like we said, round robin is server 1 takes traffic, take request, server 2 take the next, server 3 take the next until it finishes all the servers in the pool, then start the cycle all over again. Yeah, that's the way the request is, or the application gateway work. Then support protocols like HTTP, HTTPS, and this HTTP/2 is a version of HTTP traffic. It's a version. There's version 1.1. There's version 1.2. So it's just versioning, and then it supports for protection. You can use firewall to protect the resources behind the load balance, the application gateway. And you can also configure what we call dynamic scaling. So dynamic scaling of the web traffic or the web load. So if the load, depending on how much load is coming, it will tell, you can determine whether to increase this number of nodes within the infrastructure or not to increase. So moving on, while I'm waiting, let's refresh the whether to respond now. It's not responding, but I know it responded the other time. It changed to, maybe I should take it to another browser. Which browser is available? Okay, it's still showing me the same thing, but let's leave it. The thing is, it works. So continuing, continuing on the application gateway. When it comes to determining the routing for the application gateway, there are things that we need to consider. You have a choice to make here. What type of routing do you want to do for your application? Is it path-based routing or is it a multi-site routing? So when we say path-based routing, let me see if I have a diagram I can use to illustrate that. Here we have path-based routing decision that we need to make, path-based routing or multi-site routing. When it comes to path, it's referencing a particular pool of servers. They are servicing a particular they are rendering a particular service, while another pool of server is rendering another service. So meaning on the load balancer, you are going to add multiple pool. You will add pool 1, you will add pool 2 to the server. Now each of the pool are servicing, like this one now, this pool is servicing just video request, while this pool is servicing just images request. Then you have the multiple site routing decision also. This is a situation where you have multiple organizations or multiple domains, or you have some resources are still on-prem, you are running hybrid, while some are in the cloud, and you still need to be able to load balance traffic between the on-premise servers and the cloud servers, as long as they are in the same pool, right? So you can use, that's when you will use multi-site load balancing scenario. So let's go back. Do we go back? Okay, I think I should just use this slide as well. Now, when we are setting up application gateway, so you have a few things that you have to consider. When creating application gateway, one of the things you need to consider is the front end. Just like we did with the standard load balancer, you need a front end. A front end is the IP address of the load balancing that is facing the internet, or that the user request must hit. That's the front end. That's the IP or the name that user knows that they are trying to query. Now there's a listener in the middle. Listener is just majorly telling the port that is open, and it can also be based on certificate. So a listener can be configured to use port, to listen on the port, or it can be configured to say, if the request that is coming, if it is carrying traffic, or if the computer that is sending that request is having a certificate that matches the domain name that our server have, then allow it. So you can listen on certificate, you can listen on port. Then after that, it moves to the rule. Like we said, rule is to tell what to do with the traffic that it has received. And from within the rule, you have HTTP pool that you can set, where you have a combination of destination source IP, destination IP, source port, destination port, and those are the components of application firewall. Just like the standard one, you have your backend pool as well. Those are the servers that you are actually load balancing, that this rule is working for. Then you have your web application firewall. This is optional. It's for additional security on the application gateway itself. And finally, our head group. We have talked about the head group here already. So that is the way application gateway work. Let me go back to the browser Let's see if we have any of the team. Oh, they are even actually here. So now let's move on. If there's still anything on this in this particular module. So what's in the okay? We've talked about it, and we can actually move forward in this module. That is the final of the module. So now let's go back to the Azure portal to take a look at how we can create application gateway. Like we did before, you can also search here for application gateway. Because I've searched before, he brought it up for me again. So I will select application gateway. My internet to okay. So I have one, but let's see how to create one on your own very quickly. We won't finish because of how long it takes to complete the creation. We cannot wait for the activity or the process to complete, but we'll see the process for sure. It's my internet today. It's not favoring me. So again, we give name, give a name, and that's AZ. Let me see, I think I should have a name somewhere there. Now, when you come to creating application gateway, right? I think one of the things we need to even first do before we come and create the application gateway itself, we need to change some settings on our virtual network, on our VNet, which I think I've already altered. Let me go back to the resource group and we select the VNet that we are using here. I'm using this VNet 1. And in the VNet 1, we are going to create, we'll go to subnet, and we are going to create a new subnet. So I'll create a new subnet for the application gateway. We have one here called app gateway. Then we create another one, and give it 2. So 2. And also, just leave it as it is. Also, IPv4 is what we want to use. So as I select the IPv4, it will ask me now for the IP range that we want to use. So currently, we have this IP range, and we have the IP from this to this. So I'm going to use 10.60.4. Maybe 224. What's the next IP in this? /27 4.0. Subnet range is not contained in the address space. This. Okay, hold on. Let me get my subnet calculator very quickly. I have /27 224.3. Okay, let's say .224. Sorry, what am I doing? .3224. You see is already used. Use this instead. Okay, let's just /24. 0. I can't use that. So I want to still stay within the same IP. I'm using subnet calculator. Let's see which IP we can use here. We have 10.60.3.0. /27. I do /27. Okay, so I have this. Okay, so I've already used from here 222. So this is the one I used before. So I can pick this guy 193. Hopefully, I remember the one I used /27. Still complaining. If I use this or this instead, 192. The starting IP. Oh, it's the subnet I've been putting. So it's supposed to be the where the IP should start from. That's what I'm supposed to have put. Okay, so now we've specified our IP subnet range for the load balancer. And then the next thing, nothing really here. We don't need any other thing here. We click add. So after adding the gateway subnet, the next thing we can now do is to now create the application gateway itself. This has finished. Can then go back to application gateway, create application gateway. This one will stay. Application gateway. I'll say create a new one. As usual, select all this. Let's give it a name, call it 2. And then we select the tier. So we have standard tier and then WAF. That's web application gateway. But we just stay with the standard tier. Auto scaling, we don't want to auto scale. We are fine not auto scaling. How many instances do we need? 2 is okay. Then zone availability, do we want it to be redundant zonely across certain zone? It's just in one zone we need. And then HTTP 2, the version 2, we'll disable that for now because our server does not have that protocol. So now the virtual network, we need to state the virtual network that we are using. We have created we have the virtual network, then we now have to select the gateway. So in this case, we'll select this gateway that we created earlier, and we now move now to the front end. On the front end, we are leaving it as public. Public type is what we want to do, and we need to add an IP here. So a public IP, we are going to create a new public IP. Is a 104.GW, that's gateway PIP2. And we click OK. So we now move to the backend. At the backend, we are going to add the servers that we want to load balance the traffic for, and then giving it a name. Let me copy the name I already have again. Have this, and I will just add 2 to signify that then this node, we're going to leave it as node. So here we are going to select, instead of IP, we'll select virtual machine, and we'll select which virtual machine we want to load balance here. I'll be picking 1 and 2 here. Pick 1 and 2, and then we'll click add. Excuse me. So this backend have 2 targets. Now we want to split the request that we are going to be the request for each of the server that is in this. So we want video to go to 1 and image, 1 to respond to video request and the other one to respond to imaging request. So this one is also 2, and we select virtual machine again, just like we did the first one. Then here we'll add one of the server. I'm going to pick server VM1, and we say add. Then we add a third one. This one now is for image, is for video 2. as well. And then I select virtual machine again. Here I will select the second server. Then we click next, and then we go to next configuration. So now we have our front end, we have our back end. We need to create our rule. The routing rule is very important. And we give it a name here as well. Already talk about routing rule. Let's look for a name. Azure Gateway AZ104 rule. Again, add to priority. Now the priority is to know, more like priority is talking about which of the server, which one is more have higher priority or should respond than the other. So now priority is the higher the lower the number, the higher the priority. So we are going to do, I've used 10. I'm going to use 15 this time. And then we need to select we need to select a listener. I have a listener that we need to create a listener. We have to create one. So let's just give it a name. Listener, excuse me, IPv4. Listener name. Everything we are doing here is 2 because we already have. Then it's IPv4 listener we are creating, and it is HTTP. Remember, we use 80 before also, so I'm going to use 81 now so that we don't have the same issue we had earlier. Now it's a basic one, it's not a multi-site because we don't have multiple domain in this environment. Then I'll click add. Oh, before we go, backend targets. Now here, we are going to select our backend target. The target name for this is video. Yes, because I can't use that one. I've already used it somewhere else. Let's give it a new name. I will create a new target. Or let's just say I pick this backend target, for instance, and we need to pick backend setting. So here we need to add HTTP, as I have said, going to be AZ104-HTTP2. Then we change the port number again. Leave this, don't bother about this. Leave every other thing as default, and then we click add. So once we have added, we need to also, there are 2 rules that we have. We have rule, path-based rule, and then we have multi-site rule. So, and you remember that we created 2 rules to direct different traffic to different environments. So we are going to be add multiple targets to create a path rule. So now, which path? Anytime people query that IP address, the public IP, with this path, this is for image. I hope this is for image. Anytime people query that with this path, then it should send the target name is images here. Then select the backend setting that we just created and select the target setting that we created. So we pick image here and we click add. Then we add a second one. We'll add a second one for the video, which is, I'm trying to get the URL. Video, and we give it a name again, video. We select the same target that we have created earlier, and here again we select video and we click add. So once we finish adding everything here, the next thing is we click add. So we finished all that need to be added here for this application gateway configuration. The next thing we need to do is move to tag, because actually you have to go every step. Move to tag. There's no need, we are not tagging anything. Then we go to create, review, and create. So if I do review, it will just give me first the settings that I've put in place. And if I'm okay with it, I'll go ahead. If I'm not okay with it, I'll revert, go back to make these changes I want to make. So that's that. I already have one created, like I said. So let's go back there. Exactly as we just, every step is what you have seen just now. So this is the one that we have created earlier to save time, right? And these are the configuration. If you go to the front end aspect of it, you are going to see the servers that are involved. I'll be the public IP address of this particular server. So if I can copy the address to you, for you, rather, you can test it from your own side. You just add either image, or we routing through Microsoft instead of internet. Okay, so routing through, let me see from, maybe I think I should take this later, please. Sorry, I'll take the questions later because of time. So now this is the question, that'll be the gateway, the IP address of this particular gateway here. I'll post it here. So you can type it just like that, video / images HTTP. That's HTTP. If you put it on your browser, it should load and give you, it should tell you the server that I tell you for image should be different from that of the video. HTTP : same IP / video. Was there S on the video or just video? Yes, just video. So it will give you different server responding to the different service based on our configuration. Now let's talk quickly about Network Watcher. Network Watcher is a tool. Let me share my screen for that. Not so much we'll be doing there. That's my presentation. So let's quickly talk about Network Watcher, right? So Network Watcher is actually a tool or a service in Microsoft, on Microsoft Azure, that allow you to be able to gain some visibility over your infrastructure as a service resources in Azure. Your infrastructure as a service resources in Azure. So the Network Watcher have list of various tools that you can use. One of the two actually it has three main capability. One is monitoring, the other one is network diagnostic. Excuse me. One is monitoring, the other one is network diagnostic, and the third one is traffic analysis. So among the monitoring tool, you have connection monitor and you have topology. Your topology is just a view, like a graphical view of your resources, how they are connecting, which server is having connection to which server, the database server connecting to the application server, to the load balancer. It just gives you a view, like a diagram of, like a map. It's like a map of the resources of connection to one another or integration. Then you have the network diagnostic set of tools that are available with the Network Watcher. You have NSG diagnostic. So there are times that you have created a network security group and you notice that the rule that you have there, for whatever reason, is not doing what it's supposed to do. So you can use the Network Watcher NSG diagnostic to diagnose the NSG that is associated with a particular virtual network or virtual machine in your Azure environment. Then effective rule checking how effective a rule is. If my intention, for instance, is to permit HTTP request to a server in Azure from the internet, I want to be sure that it is permitting exactly that. If I make a request to want to come in through HTTPS, it should be denied, because that's the standard behavior should be denied, because I did not enable HTTPS rule for HTTPS traffic to that particular server. Then if it has to do with VPN, you can use it to troubleshoot VPN connectivity to Azure. You have what we call IP flow verifier. So IP flow verifier is also helping you to confirm the traffic flow is a particular rule supposed to allow traffic on the inbound direction, or is it supposed to allow traffic on the outbound direction? Then there are times where you just know things have been configured properly, but why is it not working? Or you want to see what are the other things that are accompanying the traffic that is coming in. So you have an environment where they have tight security requirement. They want to open just the port that is needed for a service. They don't want any other thing. So if people are now saying, if they said the port we need is port 80, and you know you've created port 80, you've allowed it, and they are launching the application and it's not opening, but the rule is there. So you can capture traffic and see maybe there are hidden ports that is coming that the service owner does not know that those ports also need to be coming to be open. So you can use packet capture. Then when we talk of nest hub, nest hub just means nest bus stop. The nest bus stop between the source of the traffic and the destination. Next hub is always the bus stop. If I'm going to maybe I want to travel now to UK, for instance, the first thing I need to move from my house, I need to move to the airport. That's my first stop there. Then depending if my plane is a straight flight, if it's a straight flight I purchased ticket for, then we are going to move right from the airport, Lagos airport, straight to UK or where I'm going, because it's straight flight. But you see, there are some times that you don't take straight flight, you say connecting flight. So each country or each state that your plane stops before you get your final destination, they are called nest hub. That is just the simple way I can help you break that down here. Then the final aspect is the traffic management or traffic analysis aspect of it. You have flow logs. What flow log does is it collects all the log of the traffic that is passing here and there and store it in a storage location on Azure. Then you can use a tool to analyze the traffic analysis tool to analyze those logs that have been collected over time and get information that you are looking for from there. That's simply what NSD does for you. I think I've already explained IP verified diagnose. So I want to verify an IP, whether this is a local IP now. I'm assuming this is a test that you want to confirm if this my own public IP, if I put my public IP and I say to come and hit this server, internal IP on Azure on a particular port. If I've not opened, this is RDP port. If I've not opened remote desktop connection to the server, it will be automatically denied. If I'm getting allowed, then something is wrong. So that's what the IP verify is for. It checks packet if packet is allowed or denied from or to a virtual machine. Then your next hub, I've talked about it. Next hub is the every stop that you take before you get to your final destination. Every stop that you take before you get to your final destination. Then topology, network topology. This is what network topology look like when it comes to monitoring with Network Watcher. It show you, if you see right now, see my VNet. My VNet shows that I have 3 subnets. I have the DMZ subnet, the front end subnet, the back end subnet. Within the DMZ subnet, I have a firewall. And the firewall, behind the firewall, I have my virtual machine server or the firewall itself that is protecting resources behind it within the DMZ zone. Then we have the front end. The front end subnet has network security group, it has its routing table, and within it we have our different virtual machines that are there. So likewise the third one as well. So that's just what a network topology look like. It helps you to visualize how resources are connected or relationship between the different resources within your environment. That is the end of this presentation. So before I move on, let me check the series of questions available for me to answer. Okay, somebody said load balancer sound like CDN. Load balancer is actually not CDN. There's difference between them. A CDN, what it is doing, that's for every other person to know, content delivery or content distribution network. What CDN is doing is to do what we call caching. So it's make response to request faster. If I, for instance, in Lagos, I'm trying to access a particular service. This is the first time anybody will access it from Nigeria, for instance. So CDN is going to look at the closest, I might have server that can respond to that particular request at different region. It's going to look at the closest region to me, and it will give me that content. Then the content is going to put it in a cache location, so that if somebody else in Nigeria, even if it's not in Lagos, in Nigeria, try to access the same thing, the response to the person is faster than when me, the first person, try to access it. That's the way CDN works. But load balancer is different. Load balancer is saying, I have two servers. How can I ensure that it's not one server that is responding to all requests? Let me distribute the load across the two servers that I have, so that one is not overwhelmed than the other. That is what the load balancer is. Now, somebody said, what is the concept behind redirection? Okay, so there are two things. One is the primary thing will be security. Primary thing is security. So there's a requirement that says if I have the port that I'm using, that the actual service, the server is the port that's the port or protocol that the actual server is configured with should never at any time be exposed to the internet. Then in that case, I'm going to expose a publicly known or general known port to the internet. But when that request gets to my network, there will be no server to respond to it, because there's no service that carry that port. So what happened is the load balancer is going to collect it and say, oh, I was told that anytime I receive a request on this port, I should redirect it to this IP address on this other port instead. That is one concept behind it. The other concept is you have services that have conflicting ports requirement. So in that case, in order for when you configure server one application or service, one with port 80, for instance, you configure another service with port 80, and they all have to pass through the same firewall, through the same IP address, for instance. So in that case, you cannot do just like you saw when we're trying to create the load balancer, because I've created something before. I've created a backend, a probe before that is a rule that is already referencing port 80 internal and 80 outside. I cannot create it again. So in that case, because you have a service that's already carrying that port internally and it's conflicting with some other port, then you will do a redirection to say, let a different port come from the user. Then when the load balancer or firewall get it, it will redirect it to the internal port that is available. That is the concept or the idea behind load balancer. So will load balancing model you recommend? taking cost into consideration. Oh, okay. So this is more of which load balancing model will I recommend. Like we said, you saw that each of the load balancers or the solutions, they are serving different purposes. Yes, some can serve more than one purpose or one use case. So depend on what you want to do really. If your intention is to protect a web application whereby the URL you give to user is not the direct URL of your web server, but a load balancer or something that is protecting it, that will first scan that traffic to see whether the traffic is malicious or non-malicious. Then in that case, you'll be looking at a web application gateway to do that. But if the intention is majorly just to distribute traffic, security is not really part of it, then you'll be looking at a network level load balancer. Now, also, what you can use to also determine is, remember we said the standard load balancer is only catering for, is a layer 4 load balancer. It's only at the transport level. That's where it operates. It does not operate up to the service or the application level. So if your plan or your need is to ensure that it's not just tell you the server is down because you could not reach it on the network, or because the port is the service running that port is down, it will go beyond it. There are times that the servers are up, they are healthy, but is the service itself, maybe because the server needed a restart, so the service stopped working until you restart the server, but the server is actually up. So in this case now, you will be looking at application level load balancer that will help you to go beyond just the transport service, go beyond just the network service, and go up to the application service aspect of it. Then somebody says, since traffic manager don't have security like WAF or NSG, is it advisable to use it? So traffic manager really he is just like, let me use a simple traffic manager instance for you. Let's say you have on your on-prem, let's go out of Azure for now. On your on-prem environment, you have multiple ISP. The primary ISP you have, you notice there were a time that when they were down, nothing works and all your data is in the cloud. Your users will not work. You decided to get a second ISP. Now, the ISP, the second one you get, they bill you every month, whether you use it or not. So as against me saying, I will just keep the ISP for backup, it's only when the primary one go down that I will use it. Then I will get a traffic manager device that can help me to say, why this backup link is up and why this primary link is up, direct a few traffic to the backup link so that it's not idle because I'm paying for it whether I use it or not. So that's in the case where you will be using traffic manager, right? Then somebody says, since it's public facing, why are we routing via Microsoft? Okay, I think I've answered that already. So you just you have the option of internet and then you have the option of routing through Microsoft. While routing through Microsoft, you have some additional security along the way or along the path to the destination. For instance, let's even say the routing that you are doing, let's say it's internal routing. Why will you tell the stuff to go over the internet? But then you say, your question says, since it's public facing. Now, since it's public facing, routing through Microsoft will give you additional security, and then there's also a kind of cost attached to it when depending on the direction of your traffic, if you have to go over the internet, right? That's just the simple explanation that I can give to you. I hope I'm able to answer your questions, everyone. So that's the end from here. So if we say quickly, let's check. Let's just see quickly one of the features of Network Watcher is to go back to our load balancer. Now here, I'm going to go to the section of monitoring, the monitoring section. Look at backend health, for instance. all the servers here should be any server that is having issue that the probe has not been able to reach will have anything other than green or other than healthy. So please give it some time. So you notice we have 4 servers here, and the 4 servers have the status code of 200. So which means they are healthy currently. So that's one of the features of the network watcher. You see the troubleshooting here as well, and the connection troubleshooting, and you see the log, and you see alerts and other things. So that's the simple. We have finished this module. Next, now we are moving on now to storage. So now let's talk quickly about storage. Storage and storage management and storage administration in Azure. The topics we are going to be covering here, we'll look at storage accounts. We'll look at one of the storage type, which is the blob storage. We'll look at security that we can have around storage, and then we'll look at how to configure also Azure file. Azure file storage is another type of storage different from blob storage. And then if we have more time, we'll look at file sync. So let me show us this whiteboard very quickly. When it comes to storage in Azure, right, there are different types of storage, and the storage varies to be able to, in order to use for different purposes. Let me put it that way, for different purposes. However, some storage are designed to be able to still host different type of data. So here now we have what we call non-relational storage. Non-relational storage are used to store non-relational databases. So when we say non-relational databases, or just let me call it structured and unstructured data. We have structured data. Structured data are data type that like table in form. They are in form of table and rows. Be in form of, yes, in a table, in form of rows and columns. They have rows and columns. So if you pick, maybe we pick Esther, for instance. We put Esther at number 1 on the row. All the attributes of Esther will be on the same row in different columns. Then we'll pick another person. We put attribute of the person, like Esther is a girl, Esther is light in complexion, and all of that. And we pick another person, maybe Aisusa, for instance, and then you say is a male and is dark, is tall. No, you just put all of those. So everything you can put on a row like that, single row, because it's organized. It is called structured data. But we also have other type of data that is called unstructured data. Unstructured data are data like images. When you snap a picture, you can't see any row or table there. It's just an image. When you image videos, you record a video, it doesn't have a row and column that you can pick from it. It's just a file. So those are unstructured data. We also have what we call semi-structured data as well. So when you come to Azure, storage, you have a way to manage it. It is being managed by what we call storage accounts, and there are different storage account types. We have storage account type for general purpose. We have for blob storage account type. We have file share storage account type, and then we have page storage account type. There are actually 4 types of storage. We have blob storage, file storage, queue storage, and table storage in Azure. So when you are configuring your storage account and your storage in Azure, they support various types of redundancy option. They support local redundancy setting option or zone redundancy setting option. They support geo redundant storage option, and then they support geo zone redundant storage. So depending on what redundancy you are looking at, and each of those redundancy options will tell you, we determine, or we have a quantity, an impact on the cost of the storage account or the storage that you are creating. Then when it comes to storage management in terms of authentication and authorization, you have different ways by which you can authenticate users to access your storage. One option is storage endpoint. You have private storage. You have either it will be private or it will be anonymously accessed. You have what we call storage access key, and you can use it based on, you can access it based on signature as well. That's certificate in this aspect. Then you have different tiers of the storage, and the tier will determine the cost. When we mean tier, we mean hot, cool, and archive. When it is hot, it means it's a type of storage that they are accessing very access continue on it, is still very active. They're still accessing it. And then talking about administration, you can replicate your storage from one data center to another data center and all of that. So we'll see more of that. And also protection. So when you delete a storage, it is initially first soft deleted. It's not permanently deleted until so you have to set a retention period for a deleted storage before it is finally deleted. And then you have what we call point in time restore. So if, let's say, you created the storage since January, and then you have the backup that is dated March. Now somebody have deleted the file permanently. You need that file. You can do a point in time restore. You restore it in a different place, location, and then you copy the content out to the new current one. Then when it comes to storage security, since you have enough security, a lot of security that you can implement around your storage. One of it, you can protect your storage using firewall. You can protect your storage using network. There's what we call private endpoint. Private endpoint means the storage is not exposed to the public, to the internet. And the service endpoint. Service endpoint is just like a private endpoint. It's an endpoint that people can reach from the internet, but there are ways you configure it. Then you can enable what we call secure file transfer. And any data that is stored in your storage is actually encrypted, and you have encryption configuration, two options. Either you use Microsoft generated encryption key, or you bring your own encryption key to protect your data. And again, authentication, different aspect. I think for this now for Azure File Share or Azure File Storage. What about access? In terms of access, you have different ways to access the content of an Azure file. One of it is using Azure File Sync. Azure File Sync is a tool that you use to copy data into a storage or move data out of the storage. Then we have other way by you mounting the Azure File Share. You mount it like a network share, and then you can do what you want to do with it. We have talked about identity, storage, and the rest. So let's go a bit deep into the storage service now. As we said, and as we can see on this screen, there are different storage type that we can create in Azure for data that can serve different purposes. Every storage that you create in Azure must be owned in a storage account. A storage account is a way, or is a method, or is like a container, a global container that contains all the account, all the storage that you are creating. They are hosted in a particular account. Now we have different type of storage. In the storage account, if you want to create a blob storage must be hosted in a container. So you must create a container that will contain where you will store all of your blob storage. All of your blob storage will be in a container. Then you have table type of storage. And here, if you look at what type of data can you store in a blob storage, you can store image data, you can store documents, you can store video. This type of storage support any type of data that you want to store in it. You can integrate it with your application, your virtual machine, and your application is writing into the storage directly. So you can take anything. Then you have table storage type. Table storage type is for structured data. You notice you see entity, and entity can be an individual, maybe a contact list. Each contact in the list is an entity, and each entity have their property. So that's what you have here. Then you have queue storage. Queue type of storage is used majorly for messaging. So I will take let's take, for instance, which example can we use now for queue storage, where you have an application that is running, and you have at every point that something happened, a message to be generated and be sent to maybe some other application. There's integration like that. Now you have a situation where the request or the traffic what is happening on that particular application is so much that there are so many messages coming at the same time. So what it does is it queue the message and start picking them one after the other to start treating them accordingly. Then you have file storage. File storage can be used for things like directories, things like departmental share, where you create a departmental share for each department in your organization, and they can use it to store different type of file. It supports text file, it supports executable file, and any type of file extension is supported within the this thing. So that's what I said. Azure Stable Storage is for structured data. Then you can store also non-relational data as well. Non-relational data, relational data in the database, in a database that is fully structured. But you can also have data that are maybe just standard Excel file as well. That is not a database, it's just a file. So moving on, right, we have different type of accounts that you can create. I think I've talked a bit about it while I was giving the overview the other time. We have different storage accounts. We have standard storage account. Standard storage account, or for general purpose storage account, can be used for most scenarios. It can be used with blob storage. It can be used for file storage, queue storage, table storage, or data lake. Data lake is for advanced, is for data, BigQuery, Azure data warehouse. Yes, those big or large data that's what data lake storage is. So then we have premium blob storage. Blob storage is used for high transaction rate or scenario that uses smaller object and require a consistently low latency. So it means you cannot accommodate too much latency or high latency on that particular resource. Then you can use storage, premium for that matter, to store it. Then for enterprise file share or departmental share, you can use file share for that. And for page storage, blob storage is for high performance page blob scenario as well. So moving on, when it comes to replication, when it comes to Azure storage account, or an Azure storage account always replicates your data to help ensure durability. It helps to ensure durability and high availability, right? So Azure storage copy contents or copy data so that it is protected from planned and unplanned maintenance or unplanned events, including transient hardware failure. So where there is hardware failure, you won't be afraid that you won't have access to your data because it will have already been replicated to another region. So you have 3 replicas. In the case of local redundant storage, you have 3 replica within a region, 3 local replica within a region, a single region. Then that's LRS, that's single region replication, give you a protection on disk and node and rack failure, right? Then you can write is acknowledged when all replicas are committed. When we mean committed, when data is being written action or writing action is happening on replica 1, for instance, or on the original, it needs to, before you can be sure, before I can tell you that all data are up to date or all storage are up to date, you need to check replica 2 and copy the content of the primary into replica 2, then copy also into replica 3. That is when you have a fully replicated data in your storage. Then we have zone redundant storage. Here is also 3 replicas, but within 3 zones, 3 replicas, each replica in its own different zone, but still within a region, within a single region still. So it also protects again or offer protection against disk, node. When we say node, is the server itself, rack and zone failure. Remember, the first one is just disk, node, and rack failure. This one now is disk, node, rack, and zone failure. So if one zone, because one copy is in a zone in the same region, if one zone fail, you still have 2 copies in the other 2 regions within this, in the other 2 zones within the same region. Then we have multi-region redundancy or replication option. Depending on the one you pick, like I said, it determines how expensive or how cheap how much you'll be paying in terms of cost, right? Now we have multiple regions. This is geo redundant region or geo redundant site or geo redundant zone. I don't even know. Okay, so now in this case, you have 6 replicas across 2 regions, 6 replicas across 2 regions, 3 replicas per region, 3 replicas per region. So, and which means they are going to, those 3 replicas in the region, it is this that it is leveraging this. The 3 replicas in the region are in different zones within that region. The second region also 3 replicas in different zones within that region. So if anything happened to a region as a whole, then you fail over to the second region. There's no way a disaster will happen in 2 regions at the same time because they are really far apart. Finally, we have that's RAGRS. Hold on. Okay, so now this final one is called read access geo redundant storage. Read access geo redundant storage. So this is based on the geo redundant storage, but it's only for read only. It's secondary, it's read only. You cannot write data into it. You can't write data. It has to be read only. So a primary one will be the one to replicate data to it. Unlike this one, you can choose to be writing data in 1 or 2 or 3. But in this case, you can't. You will only write on the primary storage and then it replicates to the secondary storage. And what is in the secondary storage is read only data. You cannot make modification or change outside of what the primary is going to replicate to it. So now replication continue, and we have still multiple regions. We have geographically zone redundant storage, geographically zone redundant storage. So this also contains 6 replicas, 3 plus 1 zone, 2 regions, that's 6 replica, 3 plus 1 zone, and within 2 regions. So which means you have your 6 replicas spread across 4 zones across 2 regions. 4 zones across 2 regions. That's the way it is. And it protects against disk, node, rack, zone, and region failure, right? Writing data to all 3 zones and copying from and copying to the secondary region can happen while you are writing. It's also copying to the secondary region at the same time. Then finally we have that's the read access geographically zone redundant region. So it's just work like the other one, the previous read access that we talk about. Now they are separate secondary endpoints, and RPO delay to secondary can be queried. So RPO is recovery point objective. If anything happens, recovery point objective means how much data are you willing to lose if you have to restore. When it comes to storage account, right? The moment you create a storage account, it gives you a URL that you are going to use to always access that storage account. That you can use to query it from outside or from application or from your computer or from over the internet. It gives you by default a storage URL, a URL that you can use to query it. Now, you can choose to create a record because the name you usually give is long depending on what you call the name. For instance, here you see container service, and each of them have different sub-level domains. For container service, you have it as whatever the storage account name is, .blob.core.window.net. For table, it is the name.table.core.window.net. For queue, it is the name.queue.core.window.net, and file at the same way. So now, if, for instance, I have this storage and I want my user to be able to access it, for instance, I will create a CNAME record to redirect anytime people query this URL, it will be redirected to this URL. So my user does not know the redirection that is happening at the background. Now, securing storage. When it comes to securing storage, one of the options you have is to use firewall and virtual network to secure your storage. And while you are configuring it, right, you have option to enable this public access, for instance. If the intention is for that storage to be reachable over the internet to your users, then you will enable public access. Now, when you are enabling public access, are you enabling the public access from a particular network or from a particular IP address or from a particular location? So if you do not want to enable access, you will disable this. If you want to enable access, you need to determine, should anybody from any network, public network, be able to reach it? Or is it from a select network or IP addresses that should be able to reach it? So this, where does this select play? If our users come to the office every time and the only place they will want to access for security purpose, maybe for compliance requirement, they can only access that particular resource or storage from our public IP that main one has given to us, or whichever network service provider we are using. So in this case, that's a scenario where we'll be making use of the second option. We have to select this and specify the IP address or network that the user will be coming from. And you also see network routing here. Determine how to how you would like to route your traffic as it travels from its source to an Azure endpoint. Microsoft routing is recommended for most customers. So now we have a demonstration to show how to create a storage account. But quickly, let's to create a storage account. Even with the way I'm going, I'm not sure I'll be able to do the second one today. Let's see wherever we stop. Okay, so now we're back on Azure subscription, and what we want to do here is to quickly create a storage account. So storage accounts, I'm going to search here as well for storage account. So search storage account. When we click storage account, it should be empty because we've not created any for now, except a monitoring tool have automatically created one for us. Then you will see, that's the only time you will see one there. Okay, so it's empty right now. So we'll create a new one. Internet move. Oh no. Okay, so we are here again, and then let's give a name to our storage account that we want to create. I have some name here already waiting. The space. See, the field can only contain, yes, can only contain lowercase letter and number. It cannot contain underscore. It's already taken. Let's see. What's today's date? 15. Okay. So we can move on, and we will select standard storage, a general purpose storage is what we are going to be creating, and we'll stick with let me say, if you notice now, by default it has already picked a redundancy option for us, so we're just going to leave it as it is. That's geo redundant storage. But considering when you are creating your own, your spending limits, your spending also have to be taken care of. You have to put into consideration the amount of credit you have. So right now, after this call, we have to do a cleanup to delete everything that has been created so that I can free up the my credit for another class. So we go next, and then here we are on the advanced tab. This internet will be evil. Okay, so here we are going to leave the information as default. There's no need, we are not interested in changing anything here, but you notice the minimum TLS. That's to access this this storage account now. It will be using TLS version 1.1, and then permitted scope for the copy operation is from any storage account to this. So any storage account. So I'm going to leave it as that. Now you say enable anonymous access on the individual container. I don't want to do that. So then enable storage key access is enabled. So we are going to leave the setting as it is here and move to the next page. And okay, maybe before I go on, just very quickly, you see the access protocol that we'll use. We have not determined yet, but the tier type that we selected is port tier. Port tier is developed or designed for frequently accessed data and everyday use scenario. And the type of enable, that's for Azure file now. We are going to, and on this storage account, for Azure file that we create, we are enabling large file share. So you will be able to take Azure file as well in this same storage. So I've clicked next. I'm moving now to the network tab of the configuration. Here, what we will just do is to disable public access. Remember, we talk about whether you want to allow access to it and from where. So currently, public access is enabled from all network. That's the default setting. If you leave it, that's how it's going to be. So I want to disable public access and use private access instead. So I don't want it to be reachable over the internet or accessible over the internet. Only within Azure Azure environment is where we need. Then we are going to move on. That's all we want to change from here. We'll move on to the data protection aspect of it. And then if you see within the data protection, you will see the recovery option. Enable point in time restore container, which means it will be doing a backup for it automatically and it will be creating different versions. So if there's anything, you can restore to a particular point in time for the particular storage that will be hosted in this storage account. Then when you delete a storage within the storage account, it will be soft deleted first before it's going to be permanently deleted. So enable soft delete for blob storage. We've enabled it there to retain deleted blob. So if you delete a blob storage now, it's going to wait for 7 days. This is configurable. It's going to wait for 7 days. After 7 days, if you did not make any attempt to recover anything from it, it will delete it permanently. The same thing happens for container, and the same thing happens for file share storage. So you can adjust this data, you can adjust this number according to your requirement. So when it comes to tracking have to do with versioning. If you are automatically creating restore points or what we call shadow copy, volume shadow copy, if you're automatically creating that, it's also going to create versioning. So you can track the version and manage it accordingly. Then access control is, I have to, just like the name say, access control, which account can access the particular storage within this storage account environment. Then we click next and we go to encryption. Now we are going to maintain using Microsoft managed key. Here it's going to generate a key by itself to be used for the protection of this storage account. So, but there are some customers that have their own key. When you select, you want to bring in your own key, it's expecting you to bring in some either key vault or certificate that you have stored somewhere. So that's just what this means. But in our case, we are going to maintain to Microsoft managed key. And enable support for customer managed key. Yes, it's enabled. If in the future we want to make that change, we can make the change. And then enable infrastructure encryption. We can do that if we want. So we'll move on. So moving on, what is left here is tag. So we're just going to say review and create. Once it creates it finish, and then we're able to access it, then we'll view the setting of the storage account. So these are all the settings that we have put, and we can go ahead and create. So it's going to take some time to create or to complete the action. So while that is going on, let's go back to our presentation. Quickly, we talk about blob storage and then implementing blob storage, right? When we want to implement blob storage, like we have said, one of the requirements that you need is a storage account. And the storage account, before you create a blob storage, you need to have a container. So, for instance, you can create container based on different purposes that you are going to be using them for. So here now, for this example, we have a storage account for production or core production. In the production storage account, we have two containers. One is for pictures or images, and the other one is for video files. So we now create the actual blob itself. Now in the blob, we have different files that we have dumped in it. We have JPEG file, different image file type. There's MPEG and what have you. Then we have video file as well. There are different ones. There's MP4. There's AV, this AVI. There are a whole lot of other ones that you can use. So the blob storage can be used to store unstructured data, just like what we see here. Pictures and video or movies, they are unstructured data, and can store any type of text or binary data. So what in essence is, it can store, if you recall, when we were checking for container, it was able to store different kind of data. So one of the data I can store is text file, or whatever text or binary data that you want to store in it. Then common use case scenario is serve image or documents directly to a browser. It storing file for distributed access, streaming video and audio directly from the internet, and then storing data for backup and restore for disaster recovery and archiving purpose. So if you want to implement disaster recovery now in Azure using the site recovery service, you will need a storage account that will contain the backup that you are going to be backing up from your infrastructure and restoring it for you. Now, when creating a container, a blob container, one of the key, these are a few important things that you need to, important decisions you need to make. That's the name, and then the access level, whether it's publicly, it should be publicly accessible, or it should be accessible only privately. That's within your organization, within your network, or within the virtual network, or within hybrid environment only. Then you have other options to say anonymous read access and anonymous read access for container and the blob storage and any blob storage in it. So you wouldn't want to select any of these two because if you are saying anonymous, it means anybody. However, you can select it but still configure your authentication for the different storage, so that still anonymous cannot be from any IP address, but somebody must authenticate before it access it. So blob storage container have unlimited, you can create unlimited containers within your single storage accounts, and then it can contain the container itself can contain unlimited blob storage, right? Then moving on, we have access tier for blob storage. For all the type of storage, we have auth tier. Auth tier are frequently used data that you access regularly on a regular basis to do your day-to-day work or job. Those are auth tier data access type. And you have code tier. Data that are not so frequently accessed, maybe you access them at least maybe once in every 30 days is when you access such data. Then you will go to cold tier. Depending on the tier, depend how fast you can recover if in case of disaster, and it also determine how fast you can write, you can read in the data, you can read to the data. Then we have cold cold tier, right? Cold tier are also for infrequent data that are also not frequently accessed, but go beyond 30 days. It extend to at least 19 days. Data that has been accessed, the last time they were accessed is about 90 or more than 19 days ago. That's they will be categorized as cold data. Then when the data is already reaching more than 19 days and nobody have accessed them in 19 days or 120 days, then you want to archive such data. So when they need it, they can go to archive to go and access it, right? That is this fourth data tier option that we have here. Adding blob lifecycle management rule, right? So when it comes to life cycle, you will be considering majorly each of the storage tiers or the access tier. You will consider them. If remember that some data that you are currently using that are being used for your day-to-day activity, at the end of the day are still going to be generating data that might become not used within 30 days. So when the data has reached 30 days and it has not been accessed, you want to move it from the hot tier, you want to move it to the cold tier or cool tier. If it's also in the cool tier and it hasn't been accessed for the next 30 days or going close to like 19 days, you want to move it away from cool tier and move it into the cold tier. And the pattern continues like that. So what you are doing in essence is you are transitioning the block storage to a cooler storage tier to optimize performance and cost. So the hot tier is the most expensive in the list and the one that have the fastest access to the data. So as you go down like that, the cost reduces, but the speed of access also reduces. That's the way it works when it comes to the different category of access to the different storage that you have in your Azure environment. And then next, we are going to determine when you are creating, one of the things you also have to bother about is the replication for your storage. So here now, for instance, we have region 1, region 2, and we have 2 storage accounts. And we also have region 3 here. So that means we have 3 storage accounts. So now I have the source storage account, let's say storage account 1, contain source container 1, and the source container 1 contain blob, they contain text file, which are blob file. And then what we want is, we want a situation whereby the storage account 1 will replicate to region 2 on maybe storage account 2 in that region 2, right? So everything that is in storage account 1 should replicate all the time to storage account 2. Now, we recall that this storage account is having multiple containers in it. So you can choose. It doesn't necessarily mean if I send storage account 1 to replicate to another region, for instance, I must also send every storage container. I must send every container to the same destination storage account. No, that's what we are saying here, that we can split the storage accounts, or we can split the containers to replicate to different storage accounts across different regions. That's the way it's helped to optimize data distribution and optimize costs along along the way, and then minimizes latency. So this another, let's go back to the browser, what's happening there. So our storage account has completed. Let's go to the resource. So this is our storage account. You notice that it contains all the different type of storage that we have: on blob storage, file share storage, queue storage, and table storage. They are all here, right? Currently, this storage account is as good as empty. There is no data, no storage in it, or no data. So let's see. So now, after this storage has been created, right here on the, we are going to go to the security and network session. So just to complete what we were trying to do earlier very quickly. So network and storage session, and then we are here. And we select the networking. Remember that we disable public access from it. Okay, recall we disable public access from it. So now we are going to select this option to allow access from a particular virtual network or particular IP address. So I'm going to be adding just for us to see how it works, right? In the firewall section, let's see. The firewall section, we're going to add IP address, my IP address. So let me check what's my IP. I go and check what is my IP. What is my IP address? So this one way for you to know the IP address you are currently browsing the internet with. This. So currently I'm browsing with this IP, right? I can copy this IP, and then I go back to the excuse me. I go back to this place and I add my IP address here. Or see, oh, I didn't even notice. It's already seeing my IP. So if I say I just check this box and it automatically add your IP address, your client IP address. So it has added it. That's the same IP it said I'm using. So that's it here. So if I have any other IP that I want to allow, I will add it here as well. Or if it's a range of IP, I will add them here as well for us to be able to. And then we have save the settings here. And then we move to data management. Under the data management, has it finished? It's still moving. So within some minutes. It's not supposed to. So now we'll go to data management. What we want to check here is to check the redundancy setting that we have in the data management section. Definitely. Sorry, I'm on data migration. I was wondering. It's data management. So I want to go to redundancy. We notice the redundancy that we have here. We chose RAGRS. That's read access geo-redundant storage. So we have one in the East US, the primary, and then the secondary one is located in the West US. So what can we do here? What we can do here is to try to configure a lifecycle management policy or rule for this particular storage account. So I'm going to create one and call it to move to pool storage. To move data from here to pool storage after the data have reached 30 days. So the scope is apply the rule to all blob storage in this storage account, to all block storage in this storage account. Then we have on the base we are going to select the block storage. That's the type that we want to use. The block, we are using block, not append. When we say append means it will do the initial one. So every time it's moving, it's going to be adding to it. But because we are saying block, so it's going to, anything you copy in January will not be the same thing as what you copy in. It will be completely different from what you copy in February and March and so on and so forth, like that. So we just click next, and then under here we are going to leave the files last modified was 30 days ago. The last time they modified the particular file in the storage that we are in this storage account on a particular storage type is 30 days ago. So if that happened, then move the file. We had a condition. Let's see, it should be move the file to cool storage. That's what we want to do. Then we'll click add. So from the storage that we created in this storage account, it will be checking, this rule will be checking across the different storage types. And if any of the data meets the rule or matches the rule that we have set in this rule, is going to take that action automatically. So now let's quickly create a blob storage within this our storage account. So we are going to container and run loading. Okay, so we're going to click new container and we call it data. So we leave this as it is and click create. Okay, that's created, finished. We go to this ellipsis. Let's check the access policy for this. Remember, talk about different access policy, access type. So now we're going to create an access policy, and it's going to be time-based access. So we want a situation by whoever or the user that will be accessing this policy. We want them to be able to, or when they access it, once it is, sorry, give me a second, let me see. Should we do that? Let's do immutable. Let's do immutable storage option, and we select time-based retention because it's time we want to use. We are going to set the retention period for this policy. In this case is 180 days. We want to, once it is 180 days, return yes. Allow protection appending rights to none. So once it is 180 days, it's going to 180 days and more is for the third tier, right? Oh, sure. Okay, so we just created a time-based access policy. So what's currently the state is on block, which means any data in the storage will still be allowed to be accessed for now. So until you reach this period, after this period, the data should be deleted. That's what it means. So that's simply how to create your container and then set certain policy against it. Let's see what else can we do here. Okay, the access policy we create soon is to show up here as well. Yes, this is here. Where's the So now, how do we get access to this storage that we have just created? You see this shared access token. Shared access token. So it's going to give us the token that we'll be using like a credential. This token will represent our credential that we'll use to access it. Whether it's a server or an application that want to come and access it, this is the token you are going to present to that application. And it's in form of a URL, right? It's in form of a URL. So we are going to create an access key or access token right now. What we want to create is account key. Account key 1 is the name, the string. Then store access policy is none. In minutes. Store access policy is none. And read permission, whether we want them to be able to read or add data. If you are adding data, you are reading and writing. That's read and write. Or you are editing. If you are editing data, if you are creating new file, editing file, you're actually performing any of these three actions. So, or whether you want the person to be able to delete. So in this case, if you don't want people to be able to delete any content, you want them to only be able to create. They will be able to create, but they can't delete anything. Even what they themselves created, they will not be able to delete it. So that's how you can put permission on all this on your storage. Then here, the protocol we want to use, definitely we want the secure one. So I wouldn't want to select HTTP and HTTPS. Then we'll say generate the SAS token. See how long the SAS token is. Like I said, it's in form of a URL. So if I want to access this now, this is what I'm going to copy. I'll copy this. My token, the URL is contained in this is the token. This from here is the token. So now, remember that, the token starts from here, rather. This is the token, rather, sorry. This is the token. And now for us to access the URL, this is the URL. The URL to the blob storage is this. Remember the name of our blob storage is called data. So the URL to the blob storage is this. This is where it's stored. Then you will now combine it with your token. So that is automatically, if I copy it and I go to another browser, let's open a new browser. Okay. And I click here and I hit enter. It should respond. So it does not appear to have any style information associated with it. The document tree is shown below. So this is an error now, but maybe I will look at it later and check what is going on. But say server failed to authenticate the resource, make sure the value of authorization header is formed correctly, including the signature. So maybe I've missed something out. So I will look at it later, but that is the simple way to generate your access token to get access into your storage accounts. Let me quickly see what we have more on the list. Okay, security, storage account security. Let's quickly cover that and we can for some time. So for your storage, like we said, you have different protection strategies that you can apply to it. First thing first is the encryption. Any data that is stored not in transit is actually encrypted in at rest. Data at rest means data that is currently not being used. It's just stored in the storage. It's encrypted. Data in transit, that's data that you are currently accessing. As at the time you are accessing it, it is encrypted also using client-side encryption, using either certificates or using the protocol HTTPS and the latest SMB protocol. Then you need to configure authentication with your Azure AD, and you can give role-based access control on the storage itself. Role-based access control is based on somebody's role, depends on how granular the permission you are giving the person will be. So then we have disk encryption, and we have shared access signature and shared key. We saw shared key in just a while ago, and we have anonymous access to containers and blob. If you have selected anonymous access in the previous setting where we're selecting the public facing, then we will be able to do this without us generating. We'll generate the key quite all right, but there will be no need for kind of authentication in it to access it. Like the error you gave us just now, that the authorization is not it's not well configured, so check it. So creating a shared access signature, right? One of the things that we need to, that's what we just did in a few minutes ago, is what we just did. You have the option of creating account key or user delegation key. Account key or user delegation key. Then you select the key string type. When you come to key exchange, you can do multiple keys so that it's going to be interchanging. But here you can only select one key at a time. So then permission, what type of permission should they have on that data or on the story? Whether it's read only, read write, read, create, add, or delete. Then you can set time. If you want expiration time for the key that you are setting, if you want it to expire, the best practice is to set the key to expire and not to be permanently available, just in case that key gets into the wrong hand. So you can easily, you will know that if you get into the wrong hand and they are not aware on time, at least the time will elapse and it will change, the key will automatically change and it will become useless to whoever have access to that key as at that time. So identify URL and SAS like we just did now. When we created the account, we had a URL and then we had the SAS that we have created. So what you need to do is to get your URL, you have to combine your token together with the storage account URL, location URL. So you have to combine the parameters together. So it includes parameters from the resource URI, storage service version, services, resource type, start time, expiration time, resources, permission, IP range protocol, signature, and so on and so forth. But at the end of the day, it's going to be this long thing is what you're going to be having at the end of the day. So I'm sure I did not combine I didn't make the combination, configure the combination well. That's why we had the error that we had the other time. So now let's see. I'm going to come back here. So coming back to the storage account, I have uploads. I'm supposed to be able to. Okay, so I want to upload a file here to So what I was looking for is the upload button. I've been looking, that's what I've been trying to look for. So now what I want to do is to try to upload file to this. I'll select my container, and here we can also try to quickly create a new one. Then let's go under the advanced. So under the advanced here, yes. Upload to folder. So you can create a folder and create a folder. Scope. We use existing default containers. So we just want to copy data into this storage. So I'm going to browse, let's select a particular data type on my PC. Go to file in downloads kind of put like text data. Let me see. This is data type. Can also quickly create a text data. Text file. Text log. So let's add one more file. Just created one very quickly called test block. Window is empty, so it will be empty. Okay, the file is not empty, I'll show you as 0. Then we upload this file. Now I have file now inside this container. Now, if we want to check, we can actually click this to see whether the content has been copied. We can use the open in Explorer. So if I click open in Explorer, to ask me now, it's asking me, I have to download Azure Storage Explorer. Let me see if I have a copy on my computer. Azure Storage, the server I have, the PC I have it on is not here, but it's not large actually, it's very small. So one way to access the resource in the storage is to go through the Storage Explorer. That's one way. Another way is you can use AZ copy to move content into the storage, but you will not be able to see the content of the storage. So for you to see the content of the storage, you need Azure Storage Explorer to explore the content of the particular storage. So now let's take a better look at the access token we were trying to create. For that, load, select review options, delete, list, copy URL, paste in private browser. Okay, storage browser. While I'm waiting for this one, can use storage browser also to browse the content of the storage. Just a minute. So let's select our container storage, blob container rather, and you should have the data. Okay, it's data, open data, and we can see the folder that we created here, and we should see the 2 files that we uploaded in the storage as well. So let's see, what can we do here? Okay, I select a file. For instance, if I select a file and I go to, I can either copy it, I go to acquire list or edit. What I want to do is I'm looking for the URL. I need to get the URL to for us to see how we can access it. The only options we have here is to upload more, delete, copy, and rename. That's majorly the only option we have here. Let me see this the same thing. Apply, and we can add more file into this particular location. So is to be able to create the URL now. Okay, you see. Okay. Oh, yeah. So you know what I just did? Select the file, the text file, and you open the file up. So these are the options I can do with this file. I can download the file, I can delete it, I can change the tier type. Currently, it should be, let's see, the type is blob, access tier is currently auth. So we can change it from auth to another access tier type. Then we can copy, see this URL. This is URL to the text document. Copy the URL. If I paste it on just paste that URL on the browser, it's supposed to give me an XML that it is not public access is not allowed. Remember that we disable public access. We only allow public access from a particular IP. But then we've not finished the permission that needs to be on it. So it's expected for what we are getting. Now, what we can do now is to generate the correct SAS now. Access key to Microsoft set account. We select key one and then we give read permission. Start date. Speak a day like yesterday. Backdate it. Expiration date should be like current date or tomorrow. Tomorrow this time. Then allowed IP address. So here I can put down my public IP that I'm allowing, but because we've already allowed my IP on this thing, I will just leave it as this and we'll leave it blank, and then let me say generate again to see what happened this time. So now that it has generated, copy this blob storage. Let's copy it to clipboard. The URL. Copy it to clipboard. Notepad again. Copy it to Notepad. This is the address of where the storage is, and then the token. Is it correct? Yes, that's the token. And let's see. There's no content in it that time. Still complaining of authorization. So I don't know where the authorization issue. Signature did not match. Oh, sugar. String to sign. The use was this. Today, tomorrow, address, authentication error. What am I missing? Let me go to in private browsers. Same. Okay. I'll troubleshoot that later so that it doesn't delay us. But that's simply how to create your storage container and then create your storage. So we can quickly see and configure or create Azure file storage. I think that one is easier. Azure file storage. If I go back now, I must come. If I go back now, I have my container already in this. I'm already in the storage account, right? Sorry. In the storage account, and we have different type of accounts. So what we do is just click on file share. Click on file share. It's coming through. Okay. So go again, click file share, and we'll add a new file share. So let's give it a name, share one. And this share input IP output maximum is 1,000, but the capacity is 5 terabytes in size, and large file share is currently disabled. So click create. Okay, let's go to next in the backup. Uh, Something is missing again. What is going on? Gosh, it's taking time. This internet will share one. We'll go to backup. What's it looking for? Okay, so I think it's taking time. Let me just quickly, I have just one slide last to show us with regards to best practice. Um, with regards to best practices, quickly take us there. Where's my slide? So here, let's quickly look at the best practices for security best practice when it comes to storage, right? One of it is to always use HTTPS to create or distribute your SAS. That's the storage token that we are sharing. You should always use HTTPS. It's more secure, and always be specific to resource, to be on which resource, that's give access to specific resources as against just general resources within the storage. Then you have what we call near time expiration time on the ad hoc SAS. Use that. You remember when we're creating the SAS token, we have the option of making it expire so that it doesn't last forever. And if that token gets into the wrong hand, it can easily, after the time elapsed, render that key useless, right? Then use storage analytics to monitor your applications to ensure that they are doing what they're supposed to be doing on the particular storage, and they're not doing beyond the read access that they have been given. So you need to be careful. You need to watch out for that rather. Then validate data written using the SAS token that you have given. If you have given a SAS token to a particular application or to a particular user, you should monitor what is being dumped or what is being written into your storage to be sure that somebody is not using the access token and they are not writing maybe a botnet or something inside that can overtake your data in that storage and even from there cross into your application. So those are a few things that you should watch out for, and don't assume SAS is always the correct choice. So if you have other choice, there are other choices rather apart from the SAS. In terms of RBAC, using Azure AD option, I'll be using Entra ID option together or in combination with RBAC. Those are things that those are ways that you can actually access or protect your storage by applying those best practices. Time has gone today. What is just left here is just Azure File Share and File Sync. If we can take it next week, it will be okay. If not, we'll see how we address it. I think I will stop there for today. I need something came up and I need to go and attend to something. So thank you. So do we have any more question, clarification so far? Thank you, John. Please do not forget they posted the URL for the attendance for today. Don't forget to don't forget to fill the form, please. Um, don't forget to fill the form. I think for every single one of us, we must have gotten access to the account that we are using for lab, and at the same time, we have been assigned to project team. So what we are going to be doing with regards to project team is for each group, each team group that we have created in on Teams or Microsoft 365 side, what we are going to do is to add the three mentors so that if you have any issue rather on the team, you will see my name indicated that mentor, you see Sarah, you see Tosin. So you can send us message and we will try as much as possible to attend to you. And if that is not fast enough, you can send an email. I think I respond to email also faster. So you can send an email and then we'll try and respond to you or try to attend to you as much as we can. So thank you very, very much for taking your time today to stay to this time. I know it's not easy for all of us, but thank God for a lot of us in Nigeria. At least we have Monday and Tuesday for holiday. So this, I think that's one of the reasons I asked if we could stay a bit longer. And I couldn't even achieve, yeah, I couldn't achieve what I was planning as well. I couldn't cover what I wanted to cover as well. It looks so easy, but we thank God for strength as well. And I really appreciate you guys even staying to the end. Like I said, it stays a lot and it gives us even more, it encourages us more to want to be willing to give more. So as much as we can, we'll try to assist you as much as we can. So thank you. In the absence of no additional question, please let's call it a day.